Hello viewers, I'm your instructor Said Ali and you are watching the channel ZQ Tech. Before starting the video, you must know I will briefly explain the fundamental concepts of inclining experiment. Which concept shines in your mind when you listen the word inclining experiment? You are thinking of inclining as bending tilt. Yes, you are right. So move forward to the definition of inclining experiment. This experiment is about the bending or healing by moving the weight over the ship body when ship is static. So consequently, it will give us metacentric height and kg, keel to center of gravity distance. Both are interlinked. Conditions for the experiment. These conditions must be met before starting the inclining experiment. No wind or waves. Ship is upright and completely constructed. No free surface effect. We will talk about the free surface effect in the further videos. 4 weights of equal masses will be used. And G and W must be known before doing or starting the experiment. I suppose for this video that you must know the points K, G, B and M points on the ship. If you don't know these points, then later in the video you will understand these points. So don't worry about these points. So let's start the experiment. Here are the 4 weights. We will place these weights in this manner on the ship. 2 on the starboard side and 2 on the port side besides each other. And again, I suppose that you know terms starboard and port side in case of ship. And here we are considering the front view of the ship, and these are the weights placed on the ship. So now we start the experiment. Basically, I will tell you the brief idea of this experiment. We will move the weight from starboard side towards the port side one by one. We have only 2 weights, so we will move 2 weights from starboard side towards the port side one by one. And after this, we will replace those weights towards the starboard side. And again, we will repeat this scenario in case of the port side, and we will move the weight of port side towards the starboard side. And hence, in this way, we have obtained on 4 values of GM. So let's start the experiment. Probably you have understand what I have said. The weight is moved from starboard side to the port side, and as a result of moving this way, the ship gets tilted. And again, we move another weight from starboard side to the port side, and it will tilt further. Now we replace back these weights, and again ship will come back to its original position. Later in the video I will tell you about the points G0, G1. So here come the slide. G0 is basically the original center of gravity of ship. G1 is basically represent the position of GNR before it tilt or heel. And one thing you must remember that the term tilt, heel, bend means the same. Even the rolling mean the same. And in this case, B' is the new center of buoyancy. M is the metacenter. H is basically the distance up to which the inclined weight is moved. Phi, this is the angle of heel. And that is the weight of ship, capital W, acting downward. And we will take the weight of inclined weight as small w. We can calculate the healing angle by placing pendulum in fore and aft of the ship. So here you can see that a triangle is forming G0, G1 and M. That is the right triangle, and on the basis of this triangle we will find out the value of G0 M. G0 M is basically the metacentric height we have to find out. So hence again, before starting the mathematical expression for G0 M, you must know the points metacenter M, G0 which is the center of gravity, B the center of buoyancy before tilt, and K is keel. From the right triangle, tan phi is equal to G0 G1 divided by G0 M. And from the right triangle, G0 M is metacentric height, where G0 G1 is basically the inclined weight moved to a distance divided by weight of the ship. So this is the formula. Replace this formula in tan phi. We will get this term W steric H over G naught M steric W. So hence we obtained the formula of G naught M. Now we will calculate for all moved weights Gm and take an average of values to get G naught M. So in our case, in case of the inclining experiment, we will move two weights towards the port side, and after that we moved two weights towards the port side. I think you have understand this thing, that first we will move two weights from starboard side towards the port side, and after this we will move two weights from the port side towards the starboard side. So hence we will obtain four values of G naught M, and we will take the average of these four values to get our mean G naught M value. In this case, kg is calculated for loaded ship weights. So with inclined weights, ship is known as loaded ship. So that is the formula of kg, where km is obtained from the graph curves of form using the draft T of ship. If there is no graph, then you can use this formula to find out km. Put the value in the above formula. And some complementary things you should know, that kb is basically the centroid of waterplane area of ship. Bm from center of buoyancy to metacentric distance, which is also known as metacentric radius. Its formula is moment of inertia over displaced volume of ship. Light condition of ship means is without any fuel, cargo, crew. Means there is no fuel, no crew on the ship, and no cargo is placed on the ship. So in that light condition, the kg formula will be. So you can use these books as your reference books. This is the end of experiment. Hope you liked my video. Any queries, comment below. I will sort it out. Thanks for watching.